All right, let's try this again. I recorded this video earlier and I didn't share my screen apparently. And you can hear me talk, but you couldn't hear me right. So here we go. Let's try this again. Suppose we were asked to take these derivatives, A, B, C, and D. Would it be possible? Part A, 2x plus 5 squared. We can multiply that out pretty easy. That's just 4x squared plus 20x plus 25. And we can definitely take that derivative pretty simply. So yes, part A, we could definitely take the derivative with what we've learned so far. Part B, yes, we still could multiply this out, but it wouldn't be very convenient. Like, we don't want to do third power, but we could. Sixth power, yes, we still could multiply that out. It would be very time consuming, very taxing, but we could multiply that out. If we looked at part B, though, like, what is the square root of 2x plus 5? That's really 2x plus 5 raised to the 1/2 power. And could we actually multiply that out? No, we can't. So based on what we've done so far, we actually can't take a derivative based on what we've learned so far. So that introduces a new method to help us take derivatives. The first notation here is kind of confusing. It says y equals f of u is a differentiable function. So we're looking at u being some other function like g of x. So this first notation, dy dx, is equal to dy du. So we're looking at like the derivative of the outer function with respect to the inner function times the derivative of the inner function with respect to x. I don't like that notation, and you'll probably never see me write that notation ever again. However, this notation I'm going to use quite often. So what we're going to do here is we're going to take the derivative of the outside function, which is f, so f prime, but the inside function doesn't change. So we're going to leave the inside function alone, and then we're going to multiply that by the derivative of the inside function. So you can think about this as derivative of mama, leave the baby inside, and then take the derivative of the baby, mama being the f here, the baby being the g. So if we were to take the derivative of 2x plus 5 using the chain rule, we don't really want to multiply this out unless we absolutely have to. We can take this derivative pretty easily with the chain rule once we understand it. The chain rule is a bit confusing at first, but once we understand it, it's really a great tool to have for us to take derivatives. So we have something being raised to the second power. So think about like x squared. What would the derivative of x squared be? The derivative of x squared would just be 2x. So what's the derivative of something squared? Well, it's just 2 times that something, and that something was 2x plus 5 this time instead of just x. But then, because there is something inside the parentheses instead of just x, we have to multiply that by the derivative of the 2x plus 5, which would be 2. And then we can multiply this together to make it look a little bit nicer. 2 times 2 is 4 times 2x plus 5. And we can distribute the 4 if we want and get 8x plus 20. Typically, chapter 9 typically takes about 2 days to teach. So we're going to break it down into 2 different videos. In today's part 1 video. So check back on Blackboard and you can find part 2 when this video is over. All right, so without the chain rule, we would have to multiply this whole thing together. So if we were to multiply this together, I would probably do 2x plus 5 squared first, because I can do that without really working anything out. And that's going to be equal to 4x squared plus 20x plus 25. And then we're going to multiply that again by 2x plus 5. We can distribute the 2x to those 3 things. 2 times x squared, or 2x times 4x squared, would be 8x to the third. 20x times 2x is 40x squared. And 25 times 2x is 50x. And then we're going to distribute the 5 to everything at the same, just like we did the 2x. 5 times 4x is 20x squared. 5 times 20x is 100x. And 5 times 25 is 125. So then we can combine our like terms for that. We get 8x to the third plus 60x squared plus 150x plus 125. So that's what f of x equals. So then we can take the derivative of that. Once we multiply it out, taking derivative is pretty easy. 3 times 8 is 24. We subtract 1, we get x squared. 2 times 60 is 120. We subtract 1 from the exponent, we get x. And 150 is just 150. To work this out with the chain rule, it would be a little bit quicker, a little bit more efficient than multiplying it out. There's nothing wrong with multiplying it out. But if we were to work this out with the chain rule, it would be a little more efficient. 2x plus 5 to the third power. So we have something raised to the third power. So the derivative of that is going to be 3 times that something raised to the second power. And that something is 2x plus 5. And then we have to multiply that by the derivative of the 2x piece, the derivative of the inside piece, which is 2. And then we multiply the 3 and the 2 together, we get 6 times 2x plus 5 squared. 2x plus 5 squared is 4x squared. 2 times 5 is 10. We have 2 of those, and 5 times 5 is 25. We multiply those together. 6 times 4 is 24x squared. 6 times 20 is 120x. And 6 times 25 is 150. And if we compare those two, compare these two, that one and that one, we see that they are the same. So chain rule does work. All right, number 2, 2x plus 5 to the 10th power. While we could do this without the chain rule, it would take forever. And we don't really want to do that. So we're just going to hop right into the chain rule. F prime of x. We have something raised to the 10th power. So this would be power rule. We'll talk more about that in a minute. So we're going to take derivative of something to the 10th power is 10 times something to the 9th power. But then since that something is not just x, we have to multiply by the derivative of that something, which is 2. And 10 times 2 is 20. 2x plus 5 raised to the 9th power. And then we don't have to multiply that out. It would be crazy to try to multiply that out. All right, number 3. We can rewrite number 3. This 2, we can move to the top, the exponent of 2. And that's going to become 2x minus 5 raised to the negative 2 power. And then we can use chain rule to take that derivative. Something raised to the negative 2 power. The derivative of that is negative 2 times something. We're going to subtract 1 from that exponent. Negative 2 minus 1 is negative 3. We do not change the something. It stays the same. And then we multiply that by the derivative of whatever that something was. And the derivative of that was 2. And then we can multiply the negative 2 and the 2 together, and we get negative 4. And at the same time, we can move this negative 3 to the denominator to make it a positive 3. So we get 2x minus 5 raised to the 3rd power. All right, number 4. I'm pretty sure number 4 is the same problem that we looked at earlier that we said, well, there's just no way that we could multiply that out. But with the chain rule, we can find that derivative. So we have something raised to the 1/2 power. The derivative of that something, slope of the tangent line, is equal to 1/2 times that something raised to the, we're going to subtract 1. 1/2 minus 1 is negative 1/2. We're not going to change the 2x minus 5. It's going to stay the same. And then we're going to multiply that by the derivative of the 2x minus 5, which is just 2. And 2 times 1/2, those are going to cancel out. And then we can make this a positive 1/2 in the denominator. So we get 2x minus 5 to make that exponent positive to the positive 1/2. And if we wanted to, we could rewrite that as a square root, since 1/2 power is a square root. All right, number 5, we're looking at 1 over 4x minus 3. We can do that. The quotient rule, the chain rule. Typically, I don't like using quotient rule. I'm going to show you that there's sometimes that we don't actually have to use quotient rule. And this would be one of them. Low D high minus high D low all over low squared. So F prime using the quotient rule. We got the low, which is 4x minus 3, times the derivative of the top. Derivative of 1 is 0, minus the top, times the derivative of the bottom. 4x minus 3 is 4, all over 4x minus 3 to the second power. 0 times this 4x minus 3 is going to go away. Negative 1 times 4 is negative 4, over negative 4 over 4x minus 3 raised to the second power would be our derivative. If we do this with the chain rule, we're going to rewrite this as 4x minus 3 raised to the negative 1 power. And then when we take the derivative, we're going to use power rule here. The negative 1 is going to come in front, times the something, whatever that something is. We're not changing it. We're going to subtract 1 from the exponent. Negative 1 minus 1 is negative 2. And then we have to multiply that by the derivative of this inside piece, which is 4. And then we can multiply the negative 1 and the 4 together. We get negative 4. We divide by 4x minus 3 to the positive 2 power if we want to make that exponent from negative to a positive there. And we do see that we did get the same answer both times. Do number 7 in a similar fashion. F prime of x is equal to something raised to the 2/3 power. The derivative of that is going to be 2/3 times the something. We're not going to change. And we're going to subtract 1 from the 2/3, which would be minus 3 over 3, which would be negative 1 over 3, times, we got to take the derivative of the something. The derivative of 7 is just 0. The derivative of negative 4x squared is negative 8x. We can multiply the 2 and the negative 8x together. We get negative 16x on top. And we can move the 7 minus 4x squared to the negative 1/3. We can move it to the denominator to make it positive 1/3. And we are done with number 7. One thing about watching the videos like this, the good thing about them is that you can pause them, you can rewind them, and you can rewatch them as many times as you need to. Number 8, we can rewrite this as negative 5 times x squared minus 4x plus 1 raised to the 1/2 power. And we're going to take the derivative using the chain rule. So negative 5 times something raised to the 1/2 power. You can think about this as like negative 5 times, let's call it v to the 1/2 power. Well, the derivative of that is going to be negative 5 times 1/2 v. We're going to subtract 1 minus 1 to the negative 1/2, but then we have to take the derivative of whatever that v was, whatever that inside function is. So that's going to look something like negative 5 over 2, because negative 5 times 1/2 is negative 5 over 2. We're not going to change this inside piece. It's going to stay the same. We're going to subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. And then we're going to multiply that by the derivative of x squared minus 4x. And the derivative of that would be 2x minus 4. And we technically would need that in parentheses since that's a quantity that we're multiplying by. We can clean this up a little bit. We get negative 5 on top. We get 2x minus 4 on top. And in the denominator, we get 2 times x squared minus 4x plus 1 raised to the 1/2 power. And if you wanted, you can switch that 1/2 power back to a square root if you wanted to. All right, so far we've learned 3 basic forms for differentiation. Other than constants, problems are written in these 3 forms. The first form that we really learned is the power rule. This is really an expression raised to a power. We learned the product rule, which is really 2 expressions being multiplied together. So let's call it expression 1 times expression 2. And then we also learned the quotient rule, which is an expression divided by an expression. Let's call it expression 1 divided by expression 2. Why is the chain rule not one of these main basic forms? Because the chain rule is always in play. If we're doing power rule, we may have to use chain rule. If we're doing product rule, we may have to use chain rule. If we're doing quotient rule, we may or may not have to do chain rule. So the chain rule is always in effect. Even if we're taking the derivative of something like 7x squared, this x would be our something. So the derivative of that, let's call it y prime, would be 14x times technically the derivative d dx of the x piece. And the derivative of x is just 1. So this would just be 14x times 1, which is just 14x. So even if we use the chain rule here, if the inside function is just x, it still works out because derivative of x is just once, or is just 1. So once we apply our derivative rules, we have to figure out how far we can go to simplify these. And this is not necessarily the hard part, but it's a lot of algebra skill. And we want them simplified as much as possible. I'm going to show you what they might look like. I'm going to do 10 and 11 on this video, and then we'll stop there for today. And then you can watch the other video probably the next day. Or if you feel like watching the next video, you can go ahead and watch it today. We got a product here. X squared is our f. And this 2x minus 3 to the 4th power would be our g. So we are looking at a product rule here, one of our 3 main forms. This would be product rule. And remember, product rule is f prime g plus g prime f. So we're looking at the derivative of x squared is 2x. We're not going to change the 2x minus 3 to the 4th power. We're going to take the derivative of the 2x minus 3 to the 4th power. And this is where like chain rule is going to come into play. So what is the derivative of 2x minus 3 raised to the 4th power? That's what we're looking at. So the derivative of that would be, maybe, come on. So the derivative of that, there's a 4 there, maybe. Come on. There we go. All right. So the derivative of that would be 4 times the something raised to the 3rd power times the derivative of that something. And now simplifying this, we want to like factor this out. We got some GCFs floating around in here. Actually, I forgot the f part. I didn't put the f part there. F is x squared. So let's go ahead and write that down. All right, so we're good now. All right, so this first part, I can't really do anything with that. That's just 2x times x minus 3 to the 4th power plus 4 times 2x squared would be 8x squared times 2x minus 3 to the 3rd power. All right, when we talk about simplifying, this would be like our 1-star answer. We can make this look a little bit better. On a free response question, may not necessarily be necessary, but on multiple choice, we may need to simplify it. So let's look at 2x and 8x squared. What do they have in common that we can factor out? And they have a 2x in common. And then we're also going to look at the 2x minus 3 to the 4th power and 2x minus 3 to the 3rd power. How I like to explain this, like 2x minus 3, obviously they have in common, but how many factors of 2x minus 3 do they have in common? So do they both at least have 2x minus 3 to the 1st power? Yes. Do they both at least have 2x minus 3 to the 2nd power? Yes. Do they both have at least 2x minus 3 to the 3rd power? And the answer to that is yes. But do they both have at least 2x minus 3 to the 4th power? And the answer to that is no. So they have 3 factors of 2x minus 3 in common. And once we factor that out, we got to talk about what would be left over. So we're going to take the 2x and divide it by the 2x. We're left with a 1. And we're going to take the 2x minus 3 to the 4th power. And we're going to take 3 factors of that away. So there's going to be 1 factor left over. Plus, we take the 8x squared. The 8x squared, we divide it by 2x, factor out the 2x. We're left with a 4x. And we had 3 factors of 2x minus 3. And we factored 3 of them out. So we don't really have any left. So that's all we're looking at. So we get 2x times 2x minus 3 squared. And then on the inside here, if this wasn't a 1, we could distribute it. But since it's a 1, it really doesn't matter. And then the 2x and the 4x we can combine into like terms, and that's 6x minus 3. And it looks like we're almost done. It looks like we should be done. But there's still a common factor of 3 in here. So we can factor that 3 out. And when we factor that 3 out, we're left with 2x minus 1. And then we can multiply this 3 and this 2 together. So we get 6x times 2x minus 3 times 2x minus 1. And this 2x minus 3 should be to the third power. 2x minus 3 to the third power. And I factored the 3 out here, so I'm just going to erase that. That was just like an intermediate step to show us where we had factored that out. And that should be a 3. And this one right here should also be a 3. So now when we're talking about answers, like what is this answer? This would be our 5-star, completely simplified answer. And the number 11. Number 11 is product rule, because we have an expression times an expression. This 4 minus x squared is really to the 1/2 power. So we're looking at product rule, f prime g plus g prime f, or however you want to remember that. Derivative of x is just 1, so f prime of x would be equal to 1. We're not going to change the 4 minus x squared under the square root. And then we're going to add g prime. So the derivative of this square root of 4 minus x squared to the 1/2 part, we got to use chain rule for that. So we get 1/2. We're not going to change the inside, 4 minus x squared. We're going to subtract 1, so we get negative 1/2. And we can't forget to take the derivative of this inside piece, which would be negative 2x. All right, to clean this up a little bit, we do get the square root of 4 minus x squared. Didn't really do anything to that. This and 2 and this 2 actually cancel each other out. Oh man, I forgot to multiply by f earlier. So that would be times x. So we get negative x times 1, which is negative x squared on top. And then we can move this 4 minus x squared to the 1/2 in the denominator. All right, at this point, we have a fraction being added to a fraction. So we can actually make these common denominators, put this over 1. So we would multiply by 4 minus x squared under the square root. And we would actually have to do that on the top as well. So when we multiply this together, the square root times the square roots are going to go away. So we get 4 minus x squared minus x squared. And we can combine this into one big fraction since the denominators are now equal. And we have like terms in the numerator that we can add together. So our final 5-star answer would be 4 minus 2x squared all over the square root of 4 minus x squared. And if you look at your notes, it says your best answer is making our numerator and denominator one fraction with numerator and denominator in factored form, as factored as it can be. So this would be our 5-star answer. Yes, we could factor 2 out of the top, and we get 2 times 2 minus x squared. But really, that doesn't do us a whole lot of good. It doesn't benefit us terribly to do that.